Hi, I'm Alexander Abad from Liverpool Hope University. I will be presenting our study entitled Untethered Multimodal Haptic Hand Wearable. Haptic primary colors, as theorized by Tachi et al., correspond to temperature, vibration, and force. Previous studies combined these three haptic primary colors to produce different types of cutaneous sensations without the need to touch a real object. In this study, we present a low cost made from commercially available components, a haptic wearable with temperature, vibration, and force feedback. Vibration motor and Peltier device combined to form a vibro-thermal cutaneous haptic feedback. Moreover, a retractable ID badge holder with a small solenoid forms the kinesthetic feedback that restricts finger movement. Here is the schematic of our prototype. It has 5 sections, namely the power supply, the microcontroller, the thermoelectric, the vibration, and the solenoid. And here is our setup. The untethered haptic hand wearable has a corresponding VR hand. We use IDE to develop the firmware that controls the actuators and the Peltier device. Application software was developed using Unity, and Leap Motion Controller tracks hand movement and finger movements. Each fingertip in the VR has a contact collider that detects collision with any of the VR objects that sends signals to the corresponding wearable's actuator. Here are the results of the test. We use MPU 9250 accelerometer to measure the vibrations of the mini disc vibration motors as shown here. We use a force gauge to measure the pulling strength of retractable ID badge holder of around 1.4 Newton. When the solenoid is activated, it has 1 Newton push force perpendicular to the rotating disc of the ID badge holder. And the groove can withstand a 15 Newton tangential force capable of stopping the pulling of the ID badge string. For the temperature, we tested the Peltier device by cooling it down for 3 seconds and turning it off until it stabilizes, and warming it up by 3 seconds before turning it off again. We presented here 3 cycles with 2 Hz sampling time. Ambient temperature is around 29 C. We observed that once the Peltier device was heated up, the cooling time is twice longer than the warming up from cold to ambient temperature. In conclusion, this study presented a novel untethered haptic wearable with temperature, vibration, and force feedback that can be used for VR applications. Each fingertip has mini disc vibration motor strap using Velcro. Vibration and Peltier device were combined to form vibro-thermal cutaneous haptic feedback. Moreover, retractable ID badge holder and a small solenoid stopper form the kinesthetic force feedback that can restrict finger movement. VR application was developed using Unity, and a Leap Motion Controller was used as a hand tracking device. Vibration motors and solenoid stoppers were activated whenever the VR hand finger touches a VR object. The prototype can be used in VR, augmented reality, mixed reality to enhance our immersive experience. Thank you very much